Okay, so what do we do when we're given a little bit of information about our statements? So in this case, P is a statement and we know it's true. We could really fill that in with any true statement. So for myself, I might say, I am a math professor, or I attended EMU, I have one sister. For you, you can think of any true statement, or it could be in general. The sky is blue. Whatever it is, we know that P is a true statement, and we're also given the information that Q is a false statement. So given those two pieces of information, we now have this more complicated logical sequence here, and we're trying to decide if this entire thing is true or if it's false, given that we know that P is true and Q is false. So what we want to do is break this apart into smaller chunks, and there's no set way of how we could do it. I would probably start with the parentheses, but just for kicks, let me start somewhere else to show you how you can really start anywhere. So you see a not Q right here, and we're asking ourselves, is that true or false? Well, we know that Q itself is false, so if we have a not Q, this would mean not false. In other words, this right here would be true. Now let's move over here. Let's take a look inside the parentheses. Notice that this not sign is not just being applied to the P, it's being applied to the entire parentheses. So let's figure out the truth value of the entire parentheses, and then we can reverse it. So we have P and Q. Remember, this symbol means that both, in order for this and statement to be true, both of these have to be true. Well, P is indeed true, but Q is not true. So it's not the case that P and Q are both true. In other words, this thing inside the parentheses is false. Now we can look to the outside. We have a not false. So a not false would be true. The opposite of false would be true. So finally we're boiled down to trying to figure out true implies true. Is that true? True implies true. Well, remember, when we're dealing with an implication here, it's almost always going to be true. The only time that an implication statement will be false, or a conditional statement, we can also say it like that, is if this would be true and this would be false. I call that the broken promise situation. This if statement was met and the then statement wasn't. We don't have that situation here. We have a true on this side of the implies and a true on the right side of the implies. So because of that, the entire statement here is going to be true. Now notice that if we would have created a truth table for this more complicated statement, so remember, even with the truth table, we're going to build up very similarly, in fact, exactly similarly to the way that we just did, we could then look inside our truth table for the answer to this question. Remember, the truth table contains every possible combination of true and false values for P and Q. It gives each combination a separate row. And in our case, we have a true P and a false Q. So that would put us right here on this row. So notice that in this row, if we look at the value of not P and Q implies not Q, we get a true value. And that should match this true value. This was the same answer, just obtained in two separate ways. So when you just need a single value of the statement based on some initial conditions, you can get it more directly, or if you want, you can create the entire truth table and then just figure out which row of the table you're actually in based on your initial values.